How can baseball data bias be corrected for fairer player analysis? Imagine trying to compare two players from different eras with completely different playing conditions. It sounds unfair, right? That's where fixing data bias comes into play. Baseball data bias can skew how we see player performance, especially when looking at players from different times, teams, or stadiums. To get a clearer picture, we need ways to correct these biases. One common bias is survivorship bias. This happens when we only look at players who stayed in the league, ignoring those who left early. It makes it seem like players improve or decline at certain ages, but in reality, many poor performers leave the game. To fix this, analysts use methods to include projections for players who left early or add imaginary seasons for missing data. This way, we see a more complete story of how players age and perform over time. Another issue is how we measure player improvement. When tracking progress, some methods compare a player's current performance to their early years. But this can be misleading if we don't consider the average age of players. By adjusting the data to reflect the typical age at which players peak, we get a fairer comparison across different players and eras. Adjusting for differences in playing conditions is also important. For example, ballparks vary in size and altitude, affecting statistics. League averages change over time too. Using statistical models, analysts can adjust for these factors, making it easier to compare players across different stadiums and periods. This correction helps prevent a player from seeming better or worse just because of where or when they played. Bayesian hierarchical modeling is a powerful tool in this process. It uses information about groups of players, like their handedness or position, to set expectations for individuals. For instance, if left-handed batters tend to hit better, this info helps adjust expectations for a new left-handed player with limited data. It makes player evaluations more accurate and fair. Machine learning and simulation tools also help. They model complex game situations and predict outcomes more precisely. These models are tested repeatedly to avoid overfitting, ensuring they work well in different scenarios. This process helps eliminate biases caused by unusual or limited data. In summary, fixing baseball data bias involves using advanced statistical methods to account for missing data, differences in playing conditions, and group trends. These corrections make player analysis more honest and balanced, whether you're looking at current stars or legends from the past. It's all about making fair comparisons and respecting the true skill of each player.